Hi guys. In this video I'm going to be talking about vector addition. Okay? I already did a video on motion maps, so if that's what you're looking for, you're on the wrong video. You need to be looking at that one, not this one. Okay? Check Schoology. So let's talk about vector maps and vector addition. Okay? So a vector map is when we just have the arrows, okay? We're not adding anything, it's just a descriptor. There are lots of different types of vector maps. For example, we're going to be doing free body diagrams later on, and those are used for forces. There are other vector maps, but I'm just going to show you a couple of examples. So let's say I'm on a ship, and I'm heading east on the ship. And I head east, but there's also the wind pushing me. So I'm heading on, I don't know, 10 meters per second east. Okay? It's a vector, so I need a magnitude and a direction. So magnitude 10 meters per second, direction east. That's fine. But the wind is pushing me. And the wind is 2 meters per second south. I'm not going to be just heading straight east the whole time. I need to consider that 2 meters per second wind that's pushing me and what it's going to do. What's going to end up happening is I'm going to have kind of a diagonal motion. Okay? So this right here, let's highlight it in a really ugly color scheme. This would be my vector map. Okay? Just the arrows put together, that's all. That would be my vector map. Let's use this example and do some vector addition. Well, actually, we're going to come back to that. Now I'm thinking about it. Yeah, we're going to come back to that. Let's just talk about basic vector addition first. Okay? So basic vector addition, I have one vector, I have another vector, I need to add them together. In this case, both of my vectors are going the same direction, and I'm going to add them tip to tail or head to tail. Okay? This little guy right here is the tail, and the arrowy part, that's the head or the tip. And I need to move this vector and transfer it over so that they're right next to each other, tip to tail. So I'm just going to see, draw my little path here. I'm going to go back to my color. Actually, that's orange. It's not red. And I'm going to draw that same vector right next to it. Great. They're both heading the same direction, so the vectors are going to add. So I'm going to, in blue, that's a nice color, in blue, create my resultant vector. That's the vector you get when you add other vectors together. So resultant. Great. What if the vectors are going in the opposite direction? Let's go back to red. I can't add them tip to tail because no matter what direction I put them, they're going to be head to head or tail to tail. So I'm just going to put them right next to each other on the same line, and you'll be able to see what you need to do. I need to subtract away the backwards motion from the forward motion. We'll just approximate that. And I'm going to end up with a shorter resultant vector from the original one right here. Great. That's basically just basic vector addition. Now let's go back and think about that ship example, because you can also use vectors and vector addition to think about moving in different directions, not along the same plane. Okay, we'll go back to that. I'll keep this blue, it's a nice blue. So I'm just going 10 meters per second east, and the wind was pushing me 2 meters per second south. Same way I did before, I'm just going to transfer my short vector over here so that it's adding tip to tail, and I'm going to draw my resultant vector. So I'm drawing from the tail of the first vector to the tip of the other. So that's my new resultant. You can figure out the numbers that vector would be, the actual magnitude and the actual degrees and direction, using Pythagorean theorem and trigonometry. So I'll go ahead and do an example of that. So, well, I'll do the direction. We'll do the trig ones later. We don't need to worry about that so much right now. So we know that this is, again, 2 meters per second over here. So we have only one missing side. So we just need to take the square root of 10 squared plus 2 squared, and that's going to give us our resultant, okay? So that's like the square root of 104. I don't know what that is off the top of my head. But that would be the magnitude, and then we would use trig to find the direction, okay? Just very basic overview of vector addition. As we have more problems and we move on into direction and forces and stuff like that, we'll have more to talk about. This is just a basic overview, okay? I'll talk to you later. Bye.